Okay, today we'd like to do the second part of our series in parallel circuits, and that is the parallel circuit. So we learned about simple circuits, and that's just when you have a single device hooked to your power source. You simply do Ohm's law and then your power equation. We then learned about series circuits, and series circuits, as you recall, has one path for the electrons to follow, like an obstacle course. They have to go through each of the obstacles separately, and because of that, they all get the same current. They get different voltages, and the toughest obstacle is the one that gets the most voltage. The toughest obstacle is the one that uses the most energy for the electrons to get through it. We saw with series circuits that if you took out one of the light bulbs, all the light bulbs would go out. We had a list of important ideas for series circuits. So today we'd like to talk parallel circuits, how they're similar and how they're different. How they're different is that they have multiple paths that the electrons can follow. So when the electrons come out of the negative terminal of the battery, they get to a junction. Some electrons can take the top path, some electrons can take the middle path, and some electrons can take the bottom path. They will all join back up again, eventually, and return back into the battery. But there are multiple paths that the electrons can follow, and that is the definition of a parallel circuit. A circuit in which there are multiple paths for the electrons to follow. In lab, I hope you guys saw some of the key ideas with parallel circuits. One idea is that if you have a 9-volt battery, each path will get the full 9 volts. Remember, this 9 volts means that every coulomb worth of charge will have 9 joules worth of energy. So regardless of which path it takes, it will lose those 9 joules per coulomb. They're all separate paths. They all get full voltage. Very important idea. You'll notice that they do get different currents, and you'll notice that the one with the least resistance gets the most current. Electrons take the path of least resistance. You'd think, why don't they all take the path of least resistance? And it's because that path of least resistance will get crowded with lots of electrons, making other options more viable. So the path with least resistance gets the most current, and the one with the most resistance gets the least current. You'll also notice the current of the battery will be the sum of the 3 individual currents, because whatever current came out had to split up into the different paths. So if you add these 3 up, you'll get your total. That will always be true. Again, if you want to find the power at any spot, you just do power equals voltage times current. Okay, so if you have a parallel circuit, it's pretty simple. You look at how many batteries there are. You use that to figure out the voltage of the battery box, and then you use that voltage for each individual path. You could then use the colors of the resistor to write down the resistance values. Again, they each get whatever voltage the battery box is. So let's say it was 9 volts. It was not 9 there, but let's just pretend. And then you can use the voltage and the resistance to get the current for the top, the current for the middle, and the current for the bottom. Once you have all those currents, you could add them up, and that will get you your total current. So I'd like you to try this one. It's an 18-volt power source. It's got 3 different paths, each with a different resistance. And I'd like you to figure out the current, the voltage, and the power for each branch. And I'd like you to find the total current and the total power. Now, when you look at a parallel circuit, each path is independent of all the other paths. So if I shut off switch number 2, light bulb number 1 will still light up. If I throw switch number 1 and turn it off, both lights would go off. So hopefully you guys see that. Switch 1 controls the entire circuit, but switch 2 controls just the one path, and switch 3 controls just the other path. So if I have a parallel circuit with 3 different light bulbs, first of all, they all get the full 6 volts. But secondly is if I take one of the light bulbs out, the other 2 light bulbs continue to burn bright. Again, if I turn out both lights, the third one still lights. They each get their own individual current. Hopefully you can see it. The electricity hits this spot and it can pick either path. If one of the paths is down, the other paths are still available. Okay, here's our pictures for a reminder of that we miss you guys and the fun that we had together. Hope to be back with you soon.